to start this one where I'm going to set up, since it's a mixture problem with percents, I'm going to draw the diagram like I did on the board for that other example. So I'm going to then look at the mixed with, and on either side of that it tells me what I'm mixing together. I am mixing 50% solution with 75% solution. The word produce is what I want to end up with. So I'm going to show my two things that I'm mixing together. I'm getting my bottles and I'm going to mix them up, and then I'm going to get my new amount. I label my bottles with their percentages. I have 50%, and then I have 75% solution, and I want to end up with a 60% solution. Then I look for my amounts because they're filled with liquid. Okay, so it says how many liters of 50%? I don't know that, so that's X liters. And I'm mixing it with 60 liters of 75%. And then to figure out what I end up with for my total liters, I just add across. So that's going to be X plus 60 total liters. To set up your algebraic equation, you just multiply your percent by your total liters. So I have 50 times X, ignore the percent symbol, 50X plus, multiply 75 times 60, and you get 4,500 equals 60 times X plus 60. Okay, so 50X plus 4,500 equals 60X plus 60 times 60 is 3,600. You're going to subtract 60X over here. You get negative 10X plus 4,500 equals 3,600. Subtract 4,500 over, you get negative 900. And the last step is to divide by that coefficient, and you get positive 9. So I want 9 liters of the 50% solution. That was my X up there. Okay, some of you did it without a picture. 90. 90, sorry. It is 90. Some of you did it without the diagram, but I think others that was a very useful method for you.
In this problem, the person is purchasing 2 different types of jam. So we want to first identify what those are. She's purchasing raspberry jam at $6.25 a jar and strawberry jam at $5.50 per jar. We also know that she's purchasing 30 total jars of jam, and then the total cost is $178.50. You can set this up with a diagram first to show what she's purchasing. So I'm going to label 2 jars of jam, and I can put the price for each. So the first one's going to represent the raspberry jam, which is $6.25 a jar, and then the second one will represent the strawberry jams that she's purchasing at $5.50 per jar. And then I have my total cost that I'm going to set that equal to. And then we want to know how many jars of each she's purchasing. So it doesn't indicate how many of each she bought, so I'm going to let X represent the jars of raspberry jam. And since I know the total jars that she's purchasing is 30, for the strawberry jam, I can take the total jars and subtract the variable X to represent the amount of strawberry jam jars that she purchased. So when I set up the equation, I'm going to take my cost associated for each jar and multiply it by my amount. So I have $6.25 times X plus $5.50 multiplied by the group 30 minus X, so $5.50. Put the expression 30 minus X in parentheses. We set that equal to the total cost, $178.50. So to solve this equation, we can next distribute the $5.50. So 625X plus 550 times 30 is 165 minus 550X equals 178.50. And so now we want to simplify the equation by combining any like terms. So I'm going to take 625X and subtract the 550X from it. And so that gives me 0.75X And now we can isolate that by subtracting the 165 away. So I get 0.75x is equal to 1350. Then my last step would be to divide by the coefficient of 0.75. So x is equal to 18. So now we go back to the beginning of the problem where we set up the diagram, and x represents the jars of raspberry jam that she purchased at $6.25 each. So she purchased 18 jars of raspberry jam, and then to figure out how many strawberry jams she purchased, you would subtract 18 from 30. So she purchased 12 jars of strawberry jam.